We're now going to review some properties of radicals. We're going to start with some basic examples to help us remember the rules. Our first example asks us to find the fifth root of negative 32. This is asking us to find a number that when we multiply it by itself 5 times, we get negative 32. The correct answer will be negative 2. The reason why is because if I take negative 2 and multiply it times itself 5 times, these two multiplied together gives me positive 4. These two give me positive 4, and then I have a negative 2. 4 times 4 is 16, times negative 2 gives me negative 32. And so since negative 2 times itself 5 times is equal to negative 32, then our answer will be negative 2. What about part B? Part B is asking us to find the fourth root of negative 16. So we need a number times itself 4 times that gives us 16. Let's try negative 2. If we take negative 2 and we multiply it by itself 4 times, let's consider what happens. These first two multiplied together gives me a positive 4. These two multiplied together also gives me a positive 4. And 4 times 4 is 16. But we need it to be negative 16. So you want to keep in mind that there's really no way to accomplish this. There's no way to take a number and multiply it by itself 4 times and have it end up being negative. And so we simply say that the answer here is not a real number. For part C, we have negative on the outside, and then we have the fourth root of 16. Well, we just showed that 2 is the fourth root of 16. Because remember that we said 2 times 2 times 2 times 2. 2 times 2 is 4. 2 times 2 is 4. 4 times 4 is 16. So I know that the fourth root of 16 is 2. And then we have a negative on the outside. And so the negative of the fourth root of 16 is negative 2. For part D, the square root of 0, this is a property that we want to remember. The square root of 0 is always 0. And in actuality, any radical of 0 is also going to be 0. So if we had the cubed root of 0, that's equal to 0. If we had the fifth root of 0, that's equal to 0, and so forth. So it's not just the square root that does it, it's any number on the root that would cause us to end up getting 0. For part E, we have the nth root of 1, and that's equal to 1. So that is saying that if we have any number n, so if I have the fifth root of 1, that's equal to 1. If I have the sixth root of 1, that's equal to 1, and so forth. When we have a negative 1 underneath the radical, the nth root of negative 1 is always equal to negative 1 as long as your number n is odd. So the third root of negative 1 would equal negative 1. The fifth root of negative 1 would equal negative 1. As long as the number here, the 3 or the 5, is odd, then the answer will be negative 1. Okay, so let's look at part F. Part F says we want the cubed root of negative 27 over 64. So let's look at this as being the cubed root of negative 1 times 27 over 64. And I'm going to go ahead and break up my radical over these two numbers, which I can do as long as they're multiplied together. So we're going to evaluate the cubed root of negative 1, and we're going to evaluate the cubed root of 27 over 64. Now, the cubed root of negative 1, we've already looked at and said that since the 3 is odd, that the answer to that is going to be negative 1. What about the cubed root of 27 over 64? That cubed root applies to both the numerator and also the denominator. So I need a number that when I multiply it by itself 3 times, it's going to end up being 27. Well, we could say to ourselves that would be 3, because 3 times 3 times 3 equals 27. And I need a number that multiplied by itself 3 times gives me 64. That might be 4. 4 times 4 times 4 does equal 64. All right, so finishing this one up, I have a negative 1. The cubed root of 27 is equal to 3. The cubed root of 64 we showed was equal to 4. And multiplying negative 1 times 3/4 gives me a final answer of negative 3/4. All right, let's look at part G. Part G asks me to find the 5th root of negative pi to the 5th. Now again, we want to look at this as being the 5th root of negative 1 times pi to the 5th. And we can break that up and look at the 5th root of these numbers separately. The 5th root of negative 1, we note that 5 is an odd number, and so we know that according to our rule up here, that the 5th root of negative 1 will be negative 1. And what about the 5th root of pi to the 5th? So I need a number that when I multiply it by itself 5 times, I get pi to the 5th. And so if you think about that, we would have pi times pi times pi times pi times pi. That is a number, pi, that when I multiply it by itself 5 times, I get pi to the 5th. So essentially what happens here is your number on the outside and your power, since they are the same, they kind of cancel each other out, and you're left with just the pi. And negative 1 times pi is going to equal negative pi. All right, and we're going to do one other example with this. This one is asking us to find the 4th root of negative 3 to the 4th. Now, and we're going to get a rule to go with this as we work it out, but let's look at working it out first. We have the 4th root of negative 3 to the 4th. So underneath the radical, let's deal with this part first, with negative 3 to the 4th. So remember that that means that we want to take negative 3 and multiply it by itself 4 times. And so negative 3 times negative 3 is going to be a positive 9. Negative 3 times negative 3 will be a positive 9. 9 times 9 will equal 81. So 81 is the same thing as the negative 3 raised to the 4th power. So I'm going to substitute that in. And now we're looking at the 4th root of 81. And again, that means that we need a number that times itself 4 times gives us 81. And so we could say to ourselves, that must be 3. We kind of see it playing out up here. 3 times 3 times 3 times 3. Does that equal 81? And I think it does. All right, and so our answer equals 3. So what we have on the slide, in addition to that problem, it says in general, if n is an even number, all right, and again, you're talking about a situation where you have the same number on the outside of the root that you have on the inside as an exponent. If this is an even number, then your answer will be the absolute value of a. Right, so the absolute value of your base. And we see that playing out here because we have an even number on the 4s. And so this rule is saying that our answer should be the absolute value of -3. And we know that the absolute value of -3 is equal to 3. However, it says, remember that if your n is an odd number, then it is equal to whatever you have right here. No absolute value necessary, it's just equal to the same base. Now in this slide, we kind of go in and summarize our different properties for radicals. We have quite a few properties that we want to just remember. Some of these we've already used. One of them tells us that, we've definitely used this one already, that we can take a square root or a cubed root of something and we can break it up and take the square root of that separately. All right, so we did that back here when we took the cubed root of -1 and the cubed root of 27/64 and we broke it into 2 problems right here. Right, that is using that first property. And you can see that they have an example listed here as well where they have a cubed root of 3x to the 6th y squared. And they've broken it up and done a cubed root of 3, a cubed root of x to the 3rd, and a cubed root of x to the 3rd. Together that makes the x to the 6th, and then a cubed root of y squared. And we'll look at some examples like that in a few minutes. Our second property says that we can break up a fraction. All right, we also did that on one of our previous examples. So if we have a root of a over b, we can do the root of the top and the root of the bottom separately. Property 3 says that if you're taking an nth root of something and then an nth root of something, that you can combine those roots by multiplication. We'll look at an example of that in just a couple of minutes. So let's keep those 3 properties in mind as we move on to our additional problems. All right, so we have 3 radical expressions that we want to simplify. So we're beginning with the cubed root of -16 x to the 8th y to the 4th. And so let's begin by looking at this. And we're going to look at each part of it separately using our first property. So we're going to break this up and do a cubed root of -16, a cubed root of x to the 8th, and a cubed root of y to the 4th. All right, now as far as our number goes, as far as the -16 goes, we need a number that times itself 3 times gives me -16. So let's try to figure that out first. What if we try 2, or maybe better yet, -2? So let's think about that. If we do -2 times -2 times -2, do we get -16? So if that is the case, we're going to have 2 times 2 is 4, times 2 is 8. All right, so that does not appear to do it for me. I'm looking for -16. All right, so let's see if we can figure out something else that might work. What I do see in doing that, though, is that I can do a cubed root of -8 fairly easily. So why don't we try to simply rewrite this as a cubed root of -8 times 2. Now let's look at that and make sure that that makes sense to us. Negative 8 times 2 is 16, the negative 16, so that is going to be fine. And the goal in doing that is to recognize that when you break this up one more time, you can actually take the cubed root of the negative 8. We showed up here that that was equal to negative 2. You cannot, however, simplify that any further, and so we'll leave the cubed root of 2. And so that part, I think, is done. All right, so let's move on to the cubed root of x to the 8th. All right, and so what we want to do is if we have cubed root on the outside, we want to try to break this thing up into groups of powers of 3. So let's see how this looks. What if we did x to the 3rd, x to the 3rd, and x squared? Now we want to be sure that we're keeping the same number of x's. So up here we have 8, 3, 4, 5, 6, 7, 8. Okay, and then we're going to break this thing up again, taking the cubed root of each part. All right, so remember that if we have an odd number here on the outside and the inside, and it's the same number, that they kind of cancel each other out and we're just left with x. So this cubed root of x to the 3rd is just going to be x. This cubed root of x to the 3rd is just going to be x. And the cubed root of x squared I can't really do anything with. All right, so we have one more term. We have the cubed root of y to the 4th. So let's look at that one. Again, let's break it up into groups of 3s. So I would have y to the 3rd and y to the 1st. And again, double check yourself. You want y to the 4th. You have a 3rd and a 1. That makes 4. Okay. We're going to break up that radical. The cubed root of y to the 3rd, the 3's sort of cancel each other out, leaving you just a y. And the cubed root of y I can't do anything with. All right, so let's put this thing together in a final answer. So let's take everything that does not have a radical. So that would be negative 2, x, and y. So putting those together, that's going to give me negative 2x squared y. That takes care of all of those terms. The other 3 terms can be merged back together under one cubed root sign. So I'm going to have the cubed root of 2x squared y. And that takes care of those 3 terms. All right, let's move on to part B. Part B is asking me to find the square root of 8 z to the 6th. All right, so again, this is a square root, and we want to group in terms of powers of 2. So let's break this up. We'll do a square root of 8, and let's do a square root of z to the 6th. Now, I know I can't take the square root of 8, so I want to think about rewriting the 8 as 2 numbers, where one of those numbers I could take the square root of. So I know that 8 can be written as 4 times 2. The z to the 6th, remember, if you have a 2 on the outside, you want to group in groups of 2 on the inside, making sure you preserve the number of z's. So we need 6 total, 2, 4, 6. Let's use our property to break this apart. And let's look at each one. So the square root of 4 we know is going to be 2. Right? But remember that it also can be negative 2, so we need to keep that in an absolute value to ensure that we have a positive answer. The square root of 2, I can't do anything with that, so I'm going to leave it as is. In each of these cases, we have problems where we have an even power on the outside and an even power on the inside. And remember that that's equal to the a value, the base, in a set of absolute values. So So this will be equal to the absolute value of z. This will be equal to the absolute value of z, and this will be equal to the absolute value of z. All right, so let's move all our terms that have an absolute value in together into one large absolute value. So I would have 2. Z times z times z would be z to the third. And I also have a square root of 2 on the outside. Okay, now the only other thing I might suggest is that having this 2 inside the absolute value is a little bit redundant because we know that the absolute value of 2 is 2, so we could possibly move that out and write our final answer like this. Okay, last problem. We're going to do a cubed root of 72x squared over y to the third. So again, let's begin by breaking up the fraction with 2 cubed roots. So I'm going to do the cubed root of 72x squared, and I'm going to do the cubed root of y to the third. We're going to group in groups of 3. So let's think about how we're going to write 72. We could write 72 as 8 times 9, and we'll keep the x squared there. All right, we're going to go ahead and break up the multiplications on the numerator of the fraction. So we have the cubed root of 8 times the cubed root of 9 times the cubed root of x squared. On the bottom, we have the cubed root of y to the third. Now, the cubed root of 8 is equal to 2. 2 times 2 times 2 is equal to 8. The cubed root of 9 cannot be done. There's not a number times itself 3 times to give you 9. So I'm going to leave that as a cubed root of 9. The cubed root of x squared also has to stay. We can't take the cubed root of something that's only squared. In the denominator, we have an odd number on the outside, and so we know that the answer to that would just be y. So let's move our terms together underneath the cubed root, and we hopefully will have our final answer. So our final answer is going to look like 2, the cubed root of 9x squared over y.